Well, good afternoon, everyone. My name is Mark Orr, and I'm the Executive Director of UK and Ireland Spill Association. And I'd like to welcome you to this knowledge-based webinar on soil sampling and analysis. I'm very grateful for OAMPS Hazardous Industries, who are the event sponsor of UK and Ireland Spill Association, and they enable these webinars to happen. I'm obviously thank you for joining us. There's a lot of people to join today, but I think we need to make a start. So soil sampling and analysis, I would sort of describe it as trying to work out through the soil what actually happened and what impact it had. And that's probably the limit of my technical competence. So the purpose of today is to teach you a lot more than I know, so that you've ended up with a little bit more knowledge of soil sampling, how to take the samples, how to do them properly, take them properly, and then actually what to do when you've got the sample, when it gets to a lab, and what to specify. So that, you know, in a sense, an environmental consultant is a bit like an inspector who's trying to work out what happened at an incident. And you need analysis to tell you, to inform you of what you're going to do next. So that's the object of this. So these are our knowledge-based webinars. The idea of them is to share our members' world-leading knowledge and enable it to be found, accessed, and shared, and as a result, enable knowledge across the world for people who work in our industry to be increased. Over time, we hope that this will become a place where those involved or interested in spill response or in incident response may come to inquire, increase their knowledge, understand what good looks like, so that they can work more safely, be compliant with the relevant legislation, and deliver a better service to their client, and to do it safely. So the idea has been during this year to run 10 marine knowledge-based webinars, and then this autumn we've been running 4 inland-focused webinars. So all of them are going to be stored on our website, and they're accessible through our knowledge base. And if you go to our website, look at knowledge base, you'll see recordings of them afterwards. We also often have related articles in Spill Alert, which is our sort of quarterly magazine, and you can find those through our website. The last issue was up last week, and the next issue will be in February. And there will be more information flows through our LinkedIn feed, and you can often pick those up on the website or LinkedIn feed, well, through our LinkedIn, and you can also pick up stuff on our website. So now you're going to hear from 2 people who actually know what they're talking about. John Axisa is the National Operations Director of Seed Environmental. He's been working in the industry for 15 years. He's been with Seed for quite a few years, and he actually runs all of their operations in the UK, Northern Ireland, and in the Republic Island, where they have their operations. Seed Environmental are members of corporate members of the association and accredited members. They're a very busy company, and they're really good guys to work with. He's going to be joined by Amy Perez-Pross, who is the associate director of Nichols Colton Laboratories. She's worked in the laboratory industry in managerial roles for the last 15 years, and she knows a lot about what she tries to make sure that when the environmental consultant says, I've got some samples, that they get the analysis, the right analysis that sample needs. So I'm going to hand over to them now so that they can tell you, and they're presenting jointly, so they can take you through the process, and so that you will learn a little bit more. And when you are out soil sampling, you end up with the right analysis. So John, I'll stop sharing and you can share.
Lovely. Thank you, Mark. Right, bear with me 1 second, everybody. There we go.
That's it. You're fine.
All right, we're off. Sorry about that, everyone.
No worries. That's fine. This is all well.
Welcome, everyone, to today's presentation. The presentation will be split into two sections. So the first section will relate to the soil sampling and will be presented by myself. And the second section about the soil laboratory analytical process will be presented by Amy. So first of all, just want to give you a little bit of a rundown as to who SEED are. SEED Environmental was established in 2013 and provides dynamic and agile spill response, consulting, remediation and restoration services to manage pollution incidents throughout the UK and Ireland. We currently employ a dedicated team of consulting project managers, engineers, technicians, in-house contractors who are experienced, trained and qualified to manage all aspects of a pollution incident, from the initial response and investigations through to risk management, site remediation, final validation and reinstatement. Our staff have extensive experience in liaison with regulators and other stakeholders, which can be essential when negotiating technical approaches, seeking information and statutory guidance, or mitigating prosecution. Several of our staff also have expert witness experience in the field of environmental science and damage. Our in-house capacity and strategically located resources nationwide ensure we can rapidly respond to urgent incidents 24 hours a day, 365 days a year. In addition to these core services, we also manage complex environmental incidents for commercial clients in the construction, energy, chemical, industrial and agricultural markets. We also design, implement and maintain in situ remediation programs on a number of challenging brownfield sites. We're members of the UK Ireland Spill Association, as Marcus said earlier, and we are also accredited by the International Spill Accreditation Scheme to standards supported by the EA, NRW, SEPA and the NIEA. We are dedicated to providing innovative and trusted market-leading environmental services and advice for our clients through responsive, agile and pragmatic solutions delivered sustainably and cost-effectively. Due to our core business interests, which I've just outlined, this presentation will focus on environmental soil sampling, with particular focus on the British Standard 10176/2020, taking soil samples for the determination of volatile organic compounds. I'll pass you over to Amy, who will then just run you through the next slide and give you a brief summary of Nichols Colton.
Yeah. Nichols Colton are part of Construction Testing Solutions. We are a leading provider of construction services. CTS have around 600 employees. As a group, we have over 1,000 clients, many of which are blue chip. We have won over 10 industry awards since 2018. We have an extensive network of laboratories for environmental chemistry and geotechnical, and we conduct 250,000 tests per year. Pass it on to John now.
Lovely, thank you, Amy. Okay, so we'll get into the meat of the presentation. So the first question we need to ask is, why collect soil samples? So if planned properly and relevant data is obtained, the collection of soil samples allows you to update your initial conceptual site model, usually generated as part of a desk study following the land contamination risk management guidance. Once your conceptual site model has been established and source pathway receptor pollutant linkages updated following the gathering of site-specific data, risk ratings can be derived for confirmed receptors, such as site users and controlled waters, as illustrated on the slide. And this will in turn dictate the requirement to carry out remediation and enable you to determine which remedial strategies are most appropriate for your site. Therefore, before setting foot on site, it is very important to understand what you hope to achieve with the information collected in the field. Different rationale are likely to require a different sampling approach. When you plan your site visit, you need to establish what your objectives are and how the sampling regime will enhance your understanding of the site. This could be to log the geological profile and identify resting groundwater levels to confirm if a migration pathway identified within your initial conceptual site model was present and therefore still of concern. Or you could be looking to confirm if specific contaminants are present at the site, and if so, how far they have migrated vertically and or horizontally through the unsaturated material. Alternatively, soil samples can also be collected to validate a site once remedial works have been completed. This can be from open excavations following source removal, or possibly from a groundwater smear zone following the completion of in situ remedial works. The site plan included in this slide shows the distribution of a series of soil bores and trial pits around an overfilled domestic underground tank, which displaced fuel at the ground surface via its vent. The sample locations were selected around the spill origin to confirm the extent of contaminant migration into shallow soils and to quantify the risks known to receptors, namely buildings and the health of site users. Based on the sampling regime, we were able to confirm the vertical and lateral extent of the contamination as a result of the spill event, and were therefore able to propose a suitable remedial strategy to reduce the risks identified to acceptable levels. Although site investigations can be planned and hotspot areas targeted for sampling, for example, around known spill areas as just shown, or chemical storage vessels, it is best to keep a dynamic view when on site. The reason for this is, within your source area, preferential pathways may be present that are only identified once you start to break ground, such as historical drainage pipes or gravel-rich beds. Contamination can more readily migrate along disturbed material associated with discrete services, and therefore may expand your area of investigation and potential remediation. The top left photo on this slide shows the point of loss and completed initial excavation beneath a failed above ground oil supply pipe, as defined during the initial site investigation. During initial remedial works, in addition to the known foul drainage previously identified, a redundant electricity cable and polyethylene drinking water supply pipes were also discovered. This instigated a further phase of site investigations, with sample along these newly identified surfaces confirming significant impact within the associated fill materials. To reduce risks to the building structures and the health of site users, and to prevent off-site migration of contamination via these preferential pathways, it was recommended that grossly contaminated material along these surfaces be removed and the surfaces replaced. Input from a structural engineer, due to the proximity of the main building, dictated that the excavation should be completed in a series of bays, as seen in the subsequent photos in the middle and on the right. During validation visits, soil samples were then collected from the sides and the base of each open excavation and adjacent to the service routes. The samples collected were dispatched to the laboratory for analysis to confirm that remedial works had been successfully completed prior to the commencement of reinstatement works. So, how do you collect soil samples? Essentially, soil sample collection will be dependent on a series of factors, most fundamental being the geology you expect to encounter and your target sample depths. Based on the analysis you wish the laboratory to undertake, you'll also need to consider the sample volumes required and the container type, such as plastic or glass, based on the expected contaminants. Amy will cover this off in more detail in the presentation later. However, it's worth noting accredited laboratories like Nichols Colton will be able to provide you with the relevant advice and correct containers on request. The British Standard 10176/2020, as mentioned earlier, states that sampling devices used for collection of samples should be made of materials that do not react with, absorb, or otherwise interact with the sample, and shall be able to withstand the forces applied during the taking of the sample without being so damaged as to compromise their proper function. Non-disposable devices shall be capable of being physically cleaned and decontaminated. It is important to be able to undertake this decontamination exercise between sample locations. Once the sampling area has been cleared for utilities, shallow soils are best collected with a hand auger or spade. Hand augers should allow retrieval to a 2-meter depth in most superficial deposits, while a spade will be limited to around 1 meter unless you plan to open up a very large trial pit. If shallow soils are full of obstructions, for example, bricks in made ground, cobble-rich superficial deposits, or shallow bedrock, mechanical excavation may be a more suitable approach and should give you access to around 2 meters for a small machine. However, you must consider the site access and the size and positioning of the spore heap generated during mechanical trial pitting. For health and safety reasons, where possible, soil samples should be collected from the excavator bucket or from the stockpile to negate the requirement to enter the trial pit or excavation. Deeper soil samples that can't be safely obtained with a hand auger or trial pit can be retrieved with a drilling rig. A competent drilling contractor will be able to recommend the most suitable drill rig or technology required to meet your scope, based on the target depth, geology, anticipated groundwater table, and site access. The most common drilling rigs you are likely to encounter for environmental sampling will be small percussive rigs, for example, Terrier or Geoprobe rigs, as seen on the left of this slide. Larger rigs capable of rotary or percussive drilling, and percussive drilling, for example, the range of Comacchio machines, and lastly, cable percussive, also referred to as Shallon auger, as shown on the top right and bottom middle of this slide, can be used for the advancement of deeper and larger diameter boreholes. To ensure that an accurate soil log is available and soil samples can be collected at defined depths, it is best to request sample recovery within a liner. This is standard for small percussive rigs, unless you are lost point drilling, and also with rotary coring and some percussive techniques used with the larger rigs. If you are utilizing a rotary auger rig, where soil risings are collected off the flight, or cable percussive, where sample retrieval from the percussive cutting shoe, getting accurate sample depths can be inherently difficult. When planning to mobilize a drilling rig to site, it is also worth considering more than just the collection of soil samples. If you are anticipating groundwater, do you want to install a monitoring well? And if so, how large a well do you require? If you think the site may require some later in situ remediation, you may want to consider a larger diameter well so that it can be used as part of any future remediation strategy. Although not specifically needed for soil sampling, for your soil sampling regime, installing a monitoring well network during this phase of works could also present your client with a future cost saving. Aside from recording visual and olfactory evidence of contamination within a sample, the standard piece of equipment taken to site by consultants to screen samples is a photoionization detector, commonly referred to as a PID. When selecting soils to screen with a PID, it is important to allow sufficient headspace around the soil samples. It is this headspace into which any volatiles will accumulate from the soil, ready for the PID to record. As such, it is important to ensure that a duplicate soil sample is collected and stored with minimal headspace to reduce the risk of VOCs being lost, should you want to submit this sample to the laboratory for analysis. The PID works by applying a high electric field to the lamp, which ionizes the noble gas stored within. This in turn creates a plasma which emits photons of a known specific energy. Photons pass out of the lamp and reach the VOC gas drawn into the PID from the sample media, which in turn is ionized. An electric charge applied to the PID sensor attracts these ions, which creates an electric current giving rise to the numerical output. The standard PID can be made somewhat more compound specific by fitting it with different lamps which emit different photons. The two most common lamps are the 10.6 EV and the 11.7 EV lamps, with the 11.7 recording a greater range of compounds, but the 10.6 being more sensitive. It is important to know which lamp your PID is fitted with, as compounds with a higher ionization energy will not be recorded on lower rated lamps. It should be noted that a standard PID is unable to differentiate between specific compounds, so the numerical output is representative of total volatile organic compound concentrations and should only be used as a comparative tool between similar soil types from the same site. The results of your PID screening on site should be used to direct your soil sample collection for laboratory analysis. Compound-specific PIDs are available for contaminants such as benzene, which includes an additional tube built into the device which screens out all other VOCs. If you are submitting highly elevated VOC samples for analysis, please remember to contact your lab, as sample dilution may be required to keep results within reporting range and prevent contamination carryover. If samples are needed for re-extraction, this could lead to delays in reporting. Amy will discuss this process in more detail later. Once soil samples have been retrieved from site and you are completing your on-site headspace VOC assessment as outlined earlier, and you're logging sample descriptions, it's important to note if your samples have been collected from above or below a water stripe. If your unsaturated arisings are clear of visual and olfactory evidence of contamination, and the PID is returning negligible concentrations, but your saturated soils at the same sampling location return evidence of contamination, it may be that you are recording a groundwater contamination issue. Further to this, if the groundwater is heavily impacted and has a layer of free-phase product present, this product can be smeared across your sample as it is retrieved from below the resting water table. When this has happened, it is easier to see with clay-rich soils, which will have an oily sheen on the outside of the core, but when broken up, the core is visibly clear of contamination or even dry. It is best to try and apply a justification to what the PID results are saying and what you have seen on site, as this will allow you to present the most suitable soil samples to the laboratory for analysis. As mentioned earlier, an elevated VOC concentration may be the result of a smear on the external soil surface. So when the laboratory results return a lower than expected concentration, it can be difficult to explain the discrepancy if accurate notes detailing your observations have not been collected on site. If you suspect that groundwater contamination may have resulted in impact to the surface of your samples, try to remove the outer impacted layer before preparing for VOC assessment. Soil with a high organic content, for example, peat deposits, can give rise to unfamiliar odours which are not necessarily contamination related. Organic rich material can also act as a sponge, and therefore laboratory results can be a lot higher than on-site observations may suggest. Recording accurate ground conditions at each sample location is therefore of paramount importance. Soil samples need to be retrieved by the laboratory in a condition that best represents the site conditions. Special precautions are therefore needed for samples suspected of having highly volatile contaminants, such as solvents or hydrocarbons. The British Standard, B10176/2020, states two principal ways for taking samples for VOC analysis. The first is to submit an intact core sealed to prevent loss of VOCs, and the second is that a small portion of the material is taken with a coring device and immediately placed in water or a preservative, which is subsequently sealed in a vial for submission to the laboratory. We at SEED adopt the first option, with all headspace being removed from the sample container. It should be noted, testing for non-volatile contaminants, for example, metals and PAHs, do not require such a specific practice. When sampling from an open excavation, it is important to ensure that the facing material is removed before you collect a soil sample. This material has been exposed to the atmosphere, and any VOCs may have evaporated or diffused from the soil or may have been leached out by rainfall. When filling sample containers, ensure that all headspaces are removed, as these would allow volatiles to partition out of the samples and be lost prior to laboratory analysis. Avoid soil samples that have been collected from within a resting groundwater body. The laboratory results could be more representative of groundwater quality than your soil sample. Stormwaters should also be removed from excavations prior to sampling as well. Sampling equipment, as mentioned earlier, also needs to be decontaminated between sampling locations to prevent contaminant carryover. Dependent on your suspected or known range of contaminants, this can be carried out with water or a surfactant solution. Caution should be paid to any hazard labels associated with your surfactants and cleaning products, as some may introduce additional contaminants to your sample. Before samples are submitted for analysis, your chosen laboratory should be updated on when to expect your samples, if they are highly contaminated, and what the contaminants are. They will also require notice if results are needed on an expedited turnaround. Once you have selected, prepared and stored your samples in appropriate containers, these should be transported to the laboratory with a completed chain of custody and in accordance with correct preservation and chain of custody procedures. I will now hand you over to Amy, who will discuss in more detail the analysis of samples once they have arrived safely at the laboratory.
So you have a new ground remediation site starting up. Of course, you want the project to run smoothly. Get in touch with the lab. SEED provides the lab with a project start date which is really useful as we can flag up the testing to the lab, especially when fast turnaround times are required. We will advise on the right containers, as John said, preservatives for your test, and the correct sample volumes. Plan well to prevent your samples from being marked as deviating. So what are deviating samples? Deviating samples are samples which have been compromised in their sampling, storage, transit, and analysis. Deviating samples may jeopardize the validity of your analytical data. Get samples to the lab in a timely manner and plan regular collections. To explain this further, here are examples of deviating samples. The holding time's been exceeded, we've got incorrect containers, it's not correctly preserved, there's headspace, the sampling date's not been provided. All this questions the validity of your data, and these samples will be identified as deviating by the laboratory. There are also risks associated with your samples being marked up as deviating. If your samples are marked as deviating, they may be questioned by the regulator. If you are using samples as part of litigation or due diligence, it can cause difficulties. Then there are cost implications if resampling is required. And of course, there's duty of care. So we will advise on sample containers, as John said. Do give us advance notice if you require a large number of containers. For volatiles, it's a 60 ml stubby jar filled to the top with no headspace, as John mentioned earlier. For TPH, CWGs and PAHs, it's a 250 ml amber jar. If your samples arrive in the incorrect containers, the samples will be marked as deviating. Again, John gave a lot of useful advice, and one of them is fully document your chain of custody. This allows us to schedule the samples straight away. We don't have paperwork, and incomplete chain of custodies is going to cause delays. If you can, comment on the samples which potentially have high levels of contaminations. Please do this. This is really useful for the labs. Another thing to mention is avoid using handwritten chain of custodies, as that causes errors. So what are holding times and why do they matter? These have been determined via EPA BS standards and in-house studies. For example, PAHs typically have a holding time of 14 days. Your samples will have to be analyzed and extracted within 14 days of sampling. The holding time starts at the sampling point. That's why you always need to enter the sampling date on your chain of custody. Holding times vary by labs and tests. Some tests have a really short holding time, such as BOD, 48 hours. You should be aware of your lab's holding times. If samples are analyzed outside the holding times, the results are likely to be lower than the expected values, and they will be flagged up as deviating. Let's look into the background of this. So compounds deteriorate at different rates. The faster the deterioration, the shorter the holding time. Light compounds such as BTEX are easily lost due to volatilization. Hydrocarbons and nitrates break down due to bacterial activity. Lower temperatures slow these down. PAHs are light sensitive, so use amber jars. Some compounds such as dioxins and furans or persistent organic pollutants take a long time to break down, so they have a longer holding time, 30 days as per EPA method 8298. Okay, your samples have now arrived at the lab. So let's walk the sample through the lab. We are going to focus on fuels. At sample reception, the samples are assessed for breakages. Deviating samples are identified. Insufficient sample volumes are noted. Low sample volumes can result in raised LODs or your samples not being tested at all or being marked as insufficient on the report. So as John said, plan your activities well and ensure you have adequate sample volumes. The samples are then logged into a laboratory information management system and given unique sample numbers and job numbers. Following sample reception, we then move to the sample prep area. There are the as received samples, e.g. for BTEX analysis, or samples that are air and dried for metals analysis. The job then moves to the organics laboratory. For extractable petroleum hydrocarbons analysis and TPH analysis, we use about 10 grams of soils, and that is extracted into a solvent such as acetone or hexane, and then sonicated. Once the samples have been extracted, they're placed into autosampler vials ready for analysis, along with quality control samples. Following that, the data is reported. That is the lab flow. We're just going to look at key tests now for fuel analysis. First one is BTEX testing. BTEX includes benzene, toluene, ethyl benzene, and the xylenes. 4 grams of as received sample is placed in a headspace vial with water. However, if a dilution is required or a retest, some subsampling is required, which will cause data variability, especially if the sample has hotspots. Let's cover petroleum hydrocarbons. Like I said, the extracted samples are placed in vials, and then only 1 microliter is injected into the gas chromatograph. Compounds are then separated by the column, the lighter compounds eluting first. Then they are detected by a flame ionization detector, which is basically a flame. The feed response is proportional to the number of carbon atoms. Note, it responds to compounds containing carbon atoms, even non-fuel. So leaf matter can cause an elevated result. Watch out for this. Following that, you will get a chromatogram. Now, John clearly explained how the PID works, and I've gone through how the FID works. And so you can now understand why there can be inconsistencies in data using the FID and the PID. Okay, now I'm going to talk about TPH-CWGs. Measuring the total concentration of petroleum hydrocarbons in soil does not give you a useful basis for the evaluation of potential risks. The TPH-CWG method is designed to characterize petroleum hydrocarbons in soil into a series of aliphatic and aromatic fractions that represent fate and transport fractions. Aromatics such as benzoapyrene pose a higher risk. At the lab, the aliphatic and aromatic fractions can be separated by using SPE cartridge or by a technique known as GC by GC, where the fractions are separated by boiling points and polarity. To determine the type of fuel contamination present in your soil, schedule a fuel ID. Fuel ID requires a chemist's interpretation. So you want to know what kind of fuel is present in your soil. Is it petrol, kerosene, diesel, or weathered diesel? Fuels have specific patterns based on boiling points, composition, and carbon chains. This is fresh diesel, and it elutes between C12 and C20 and has a specific pattern with N-alkanes eluting at regular intervals. Chemists use libraries and reference chromatograms to identify fuels. Fortunately, we've built a comprehensive library. Petrol range organics will elute first because they have light boiling points, and then you get diesel followed by mineral oil. On site, you will need to determine if it's a fresh fuel or not. Once fuels have been released into the environment, they will change as shown. They will change as shown. Hydrocarbons undergo a complex variety of processes, including volatilization, loss of low boiling point compounds, microbial degradation. The risk at a site will change with time. Biomarkers can also be used to determine levels of degradation. Chemists need to be able to identify degraded fuels. Good analyst training and comprehensive libraries are key. An experienced chemist will be able to identify degraded fuel or mixed fuels, but an inexperienced chemist may find this difficult. So, if there is a mismatch between the site history and the fuel ID carried out by the lab, request for the fuel identification to be carried out by a senior chemist. Then your results are reported. We can send the results out via email in various formats, or they can be accessed via lab portal. If the laboratory data matches your site observations, you're good to go and on track with the project. But what if you get your results back from the lab and they do not match site data observations? This can be a nightmare on site and result in delays and cost implications. For example, you could have low results for a highly contaminated site or high TPH results after remediation. So if this happened on site, John would give me a call, provide me with a bit of background, and we would raise a data query in the lab. We would recheck the raw data, sample dilutions, QA/QC, surrogate recoveries, inspect the sample labeling, and then get back to John. Data variability is an important issue. It has been covered in a number of talks, including a memorable one by Lango Rourke at an ELQF event that John and I attended. And it was called Lies, Damned Lies and Laboratory Data. So it was a memorable talk. So what they did was they took the same TPH sample and they sent it to 3 different labs. And the values varied between 1,800 milligrams per kilogram to 4,800 milligrams per kilogram. So this can't be very useful for you on site, and it demonstrates lab-to-lab variability. Be aware that although labs are UCAS accredited, they use different methods. For example, the TPHs could have cold extraction shakes, triple extractions, sonications, and then there are different solvents with varying extraction capabilities, methylene chloride, hexane, acetone, and the duration of extraction times can vary. So you may observe a step change if you change labs mid-project. I've recently presented with Murray Environmental on a case study where elevated results were seen, and this was due to a small piece of asphalt and sample heterogeneity. Other reasons include the matrix, gravel, clay, and they are more difficult to extract from, and also things like dilution errors or lab errors. So what are labs doing to reduce data variability? Well, there's a number of things, including implementing robust methods, analyst training, using the latest equipment, looking at IT solutions, automation, QA/QC, adding flags to reports to catch outlier results, and more. You also want a successful ground remediation project. How do you prevent, reduce, and resolve data queries? The answer is talk to us, talk to the labs, speak to the lab. What should you say to the lab so that we can do the best job for you? The successful ground remediation project planning is essential. Provide us with a heads up on the site background. We have even visited key sites to gain a better understanding. For example, I visited a highly contaminated kerosene spill site. When the client called and said that the TPH results were low, I jumped on it straight away and inspected the samples. The investigation revealed that there were sample homogeneity issues. Notify us of highly contaminated samples, or like example, high TWOC results, as John said. This will allow us to run the samples at appropriate dilutions, and then you will get results in a timely manner. It also reduces and prevents sample carryover from high samples to low samples. And it saves us on instrument issues, which can cause further delays. There's nothing that upsets a chemist more than instruments going down due to dirty samples. Since the collections for the seed projects were pre-scheduled, the testing was carried out within holding times. Close communication is key. Of course, an awareness and appreciation of laboratory data variability can assist the site engineer in evaluating the correlation between site history and laboratory results, as well as identifying any apparent site anomalies. Finally, talk to us. Direct access and discussions with a technical chemist can assist you with any queries that come up, and they can quickly resolve them for you. Work in partnership with your lab for successful and timely projects. I've got a quick slide there on new techniques that are out there, but I'm just going to show that for now, and then we'll move on to John's slide.
Lovely, thank you, Amy. So to summarise the talk by myself and Amy this afternoon, when you're completing a phased approach to site investigations or remedial works, a fairly standardised approach can be adopted. Firstly, you need to draft a scope of works. This will include listing the contaminants that you consider to be present on site and will be submitting for analysis and confirming how you intend to collect them. You will need to consider, will hand auger or spade be sufficient, or does a drill rig need to be mobilised to site? If you are unfamiliar with the contaminants you expect to encounter at a given site, speak to the laboratory in advance, as you may need specific containers or preservatives which need to be issued before you attend to ensure your samples are preserved correctly and do not deviate. Whilst on site, maintain a dynamic view of the site when collecting your samples. Consider each set of infield results with respect to what you're observing and make detailed notes on the sample geology, water strikes, and visual and olfactory evidence of contaminant impact. Once the site investigation has been completed, or if your phase of works is extended over several days, you will need to arrange for regular sample dispatch to the laboratory to avoid the risk of deviation and to allow the sample results to be returned in a timely fashion. When you dispatch the samples, send a completed chain of custody, and as Amy mentioned earlier, make sure that you contact the laboratory beforehand if you require a faster than standard turnaround, or if you consider your samples to be heavily impacted and will therefore require some additional preparation before being tested. When the laboratory results have been received, compare the results to your field site notes to ensure that all lines of evidence marry up. If you consider there to be a discrepancy, can you explain it based on your field notes? If not, the laboratory should be able to provide assistance, as Amy has outlined earlier, with re-extractions or further information on their analytical process, which may help to explain the results. Finally, once you're happy that the site observations and laboratory results accurately reflect the site conditions, you can update your conceptual site model and, if required, draft a remedial proposal to reduce any remaining risks with confidence. That's the end of the presentation. Thank you very much.
Thank you.
John, Amy, thank you very much indeed for that. Really valuable, lots of technical stuff there. As you can imagine, there's a couple of questions. If I can give them to you jointly, then you can pick out. I think the first one is really for you, John. This is from Pierre Lavisier, and the full question is in the chat. Before installing any staging area or waste collecting area, we sample the soil for background information to establish a baseline to compare to the samples taken after the response when the site is no longer in use. Is this a good idea?
There's a couple of things. The way we look at dealing with this is we try to minimise stockpiling soils on site as much as we possibly can. So we would always try and contain within, well, especially when we're working at domestic sites, we'd always try and contain within skips So that, or if we were going to basically be stockpiling soils and build a holding area, we would put in preventative measures to ensure that there was minimise any form of leaching of contaminants from that stockpile. So that would be the priority. It would be a case of putting preventative measures first and foremost to try and prevent that. But I don't think it's a bad idea to take preconditioned samples, especially from a Part 2A perspective, if you need to then validate the site afterwards.
Yeah.
I suppose assuming your works are already planned and targeted, you should know what contaminations you're testing for anyway. So if you wanted to do that as some additional due diligence, I don't see that that would be a problem. But I'd say from my perspective, it would be a case of try and avoid and put preventative measures in to actually prevent any secondary contamination arising at site from your activities.
Okay, that's good. Thank you for that, Pierre. I hope that's an adequate answer. Second one is from Jonathan Burton. Are you satisfied that sampling with an auger and from trial pits / excavations and analysis for VOCs, including BTEX, is compliant with BS 10176? This standard states that disturbed samples from augers and pits / excavations yield heavily disturbed material unsuitable for VOC sampling. So how are you ensuring compliance with that aspect?
I'm just going to read what John's written here. Sorry, bear with me 1 second. So just to answer the question that John's raised about the containers, we don't put preservation into our containers, especially the ones that we put to Nichols Colton, and that's their preferred method as well.
Yes, it is our preferred method, and everyone's still getting in line with the guidance as well.
In respect of the John's saying about the disturbing the samples and obviously that affecting the VOC sampling, it depends on the size of I would suggest it depends on the size of the auger and making sure that you've got an appropriate auger so you can collect a large enough sample to ensure that you're actually taking a sample which isn't then considered to be disturbed. So it's all about the core of the sample that you're collecting. So what you want to try and avoid is collecting a friable sample. I know that can't always be achieved, but you want to try and take as much of an intact core as you possibly can, and then place that to then undertake your VOC assessment. We would also look at trying to do it so that we take 2 samples, so that again, when you're then doing your VOC assessment, you can then put an intact core into your sample jar, so that that's then compliant with the standard.
Yeah. I think it's also important to clean the device that you're using to take the samples in between taking the samples. Too often I've seen people just use the same auger to sample completely differently contaminated areas and therefore taking contamination with them. Would this be a normal practice?
As I outlined in my presentation, Mark, you should sample or you should clean your instruments between every sample location. So that has to be carried out. And as I say, you can use water or you can use specific surfactants that are designed for certain chemicals. And like I expressed, you need to be careful that you don't then add other contaminants to your samples, which may then be picked up in the lab process. You also need to bear in mind, again, like we were saying before, if you go through a water strike, then that you're not then taking samples below that water strike, which are clean, but you're drawing it through the water strike, which is contaminated. Because then that will potentially conflict the results on your on-site observations.
Mike White Ken Scally has just asked, have you considered using subsoil TO15 VOC samples where the soil is then not disturbed?
No, it's a simple answer to that.
Okay, and then Mike White has asked, in the case of speed of sampling VOC, do you use NCORE samplers to collect? again stated in BS 10176. I'm not sure what an end-core sampler is.
No, as I say, we use the tech. We don't use the methods we use for sampling are the ones that we've outlined in the presentation. Those are our preferred aspects, but and methods. So no, we don't use on-core samplers to collect. No.
Okay, fine. I think I haven't got any more questions. If anyone has, pop them in and we will pick them up. The one thing could I ask is, how do you go about establishing the baseline? In other words, what was there before the incident in terms of sampling?
Sorry, say that again, Mark.
So how do you establish what the pre-incident conditions were on a site?
It's based, when we're dealing with insurance domestic claims, we are only looking at one specific contamination, which would be hydrocarbons. So from our perspective, a baseline condition would basically, we would assume, would be nothing other than if we know that there has been evidence of historic contamination. So just like you would do your due diligence, we would be looking to see whether there have been historic fuel spills at a property. The other aspect, the way that you can carry it out, is take samples from a known location which you know is unaffected by the spill. But again, it's important to take samples which are representative of the geology that you're then testing and sampling in your area of known plume. So again, if we're looking at a specific tank location which we know has leaked, the tank has failed, then we can be pretty certain, if we move to the other side of the house, for example, that we can take samples perhaps that aren't contaminated. But again, it's different for each site. But
of course it is. Yeah, I accept that. And then the next one question from Brian Mitchell, which is for Amy. What is the typical cost per sample, Amy?
So that would depend on the test that he wanted. So if he wanted TPA, CWGs and BTECs, or a full suite of tests, and he's more than happy to get in touch with me and I'll give him some costs. Yeah,
that's great. Good. I'm just going to I'll just share my screen. Sorry. Hopefully you can share mine. Okay, let me get it play for a cut slide. Okay, thank you very much indeed for those questions. That's been a really good presentation, lots of knowledge exchanged. You will note that this is being recorded, and the recording, once I've edited it, will be up within the next couple of days, and it will be available through our website. And I would, I mean, generally far more actually see the recording than are actually attend, which is good, but they're available now forever, part of our posterity. So please do watch those. This is our last webinar before Christmas. We're taking a break, and then we're back in January with two webinars. The first is on MV Wakashio, which was a big bulk carrier which actually managed to crash into a reef off the southeastern corner of Mauritius. Big incident, lots of stuff in the press. We're doing a concluding webinar just to talk about lessons to be learnt. And then on the 26th of January, in conjunction with our plastics pollution working group, we're going to be doing a marine plastic pollution webinar, some thoughts on collection, recovery and disposal. And we want to probably run another one on that, which talks about strategy and what people are doing to do with plastics. So that's our webinars for the year. Please feed in ideas. If you want to, if there's topics you think we should be covering and you want us to cover, fire them in. We'll see if amongst our 120 odd members, we can see if there's expertise to cover those topics. So that's great. Thank you very much indeed for joining. Thank you very much for all the great questions that we've had, but primarily thank you very much indeed for to our two presenters, because you covered a complicated topics such that a simpleton like me could understand. So I'm really grateful for that. And if I can understand it, then I'm sure most other people can as well. So thank you very much.
Thank you, Mark.
you.
Appreciate that. Thanks,
Thank
guys.
you very much. Have a good one, and
Thanks, everyone.
have a good Christmas. And to many of our regulars, we'll catch up with you in the new year. Best wishes. Bye bye.
Thanks, Mark. Thanks, everyone. Take care.
Thanks, everyone.